Hey guys, welcome back. So today I will be solving this problem called binary tree right side view from LeetCode 199 medium. So this is a very popular interview problem because you can be given like a binary tree and you have to find the right side view or even the left side view or even bottom view or top view. So you can be given to find out any sort of view of binary tree. So let's see what this problem is saying. Given a binary tree, imagine yourself standing on the right side of it and returning the value of nodes you can see in order from top to bottom. So what this exactly means is, let's say this tree is given and we are looking from the right side, from here where this arrow is pointing. So if we see from here, the nodes we can see from here are 1, 3 and 4. Similarly, I will be solving, not solving actually, I will be telling you how to solve the left view also in this video. So we will be solving the right view. This is exactly same, just with some minor tweak we can find out the left view also. So first let's see how to solve the right view. So for the right view we have to stand over here in the right side and we have to see which nodes are visible. Here the 1, 3 and 4 is visible. So can you guys just think of for a moment like how to approach this problem or how to solve this? So I will be telling you how to tackle with this type of problem. So whenever any tree problem is given, first of all think that we have to obviously traverse a tree. So which traversal should help us in this scenario? So if we think harder, we can see these nodes are exactly the last node of the level order traversal. Like if we traverse the tree level by level, so at the first level we have 1, at the second level we have 2 and 3, and the third level we have 5 and 4. So we see at each level the last node is the right side view, and also similarly at each level the first node is left side view. So I hope this is making sense. So if we just simply do a level order traversal and we find out the last node of this, we will find the right side view, and if we do the level order traversal and find out its first node, then we will see it is the left side view. So this is the problem, and we just have to do the level order traversal and find out the last node of it. So let's do it. So let's get to the coding part. So first of all we have to check if the tree is existing or not. First of all, if condition check, if root is none, that means the tree is not present. So directly we will return what? An empty list. An empty list because there aren't any nodes. Return empty list. Now else, for level order traversal we all know we can do it in two ways. We can do it either recursively or we can do it in iterative way using a queue. So I am in this video will be showing you the iterative approach using a queue. So first of all, let's say we are taking a queue called queue and we are pushing the root in it. Queue dot insert 0, and we all know queue is first in first out, so we will be inserting at 0th location and we will be deleting from the last, so it will be first in first out. So we will be pushing the root first. Okay, so now a simple BFS while length of queue is not empty, we will do, first of all we will do what uh, in the level order traversal. We will first find out that how many elements are there in the each level. So in level order traversal we'll know at any instance of time in the queue only those many elements will be there. How those many elements will be there, and that is equal to the number of elements in the current level. Like for first level in the queue there will be only one element, for the second level there will be only two elements. So this is how the level order traversal works. So if you don't know how level order traversal works, you can check out some videos, or I will be making one very soon also. So first of all we have to find out the size of the queue. So size of the queue is length of queue. Now for each node in the queue we have to pop it one by one. So let's do it. So let's run another loop for I in range, size. So first of all we have to pop. So let's say we pop it and store it in this variable called ele or element. So q dot pop. So we now have this element in ele. So now we have to, for each element in each level we have to check its neighbors, like it if it has left child or if it has right child or not. If they are having both the childs, we have to push them, or rather enqueue them in the queue. So before that, as I said, for each level the last element is the right side view, so we have to check that also. So how can we find out if it's the last element or not? So we are here determining the size of the queue. So if the element is the last element in the queue, how can we find out? So the index of this element will be size minus 1, as it's like a, you can think of it like queue of as an array. So the last index is what? Size minus 1. So if it's the last element, that means it's the right side view. So we will check that condition over here. If I is equal to size minus 1, then so we also need one answer array, because we need to store the answers also. So if it's size minus 1, then we will append this to our answer. So we will append element dot val or value. Now again we will check if this element has left value or not. If it has left value, then we will insert the left to the queue. So element dot left, and if it is also having right value, then also we will be inserting it in the queue. Insert element dot right. So after this whole process, this answer array would have our right side view. So at the end we have to just simply return this answer, return answer. So let's run it. So okay, so insert will be at 0. Okay, so here it is, you can see accepted. So let's just run it. So before running, okay, let me just do a simple recap of this algorithm. So we are doing just simple level order traversal. If you don't know level order traversal, please go through it once. The main trick over here is we are storing the last value of each level order traversal, and that is we are doing using this line. And also one thing to notice over here is, if we were given to find out the left view, then what we would have done is, instead of size minus 1, we would have written here I is equal to 0, because it would be the first element of the queue at each level, right? Like first element of each level, so that's why 0. And because it's a right view, that's why we're writing size minus 1. So this is the tricky part, and we are appending it in the answer, and rest of the part is simple level order traversal. So let's just submit it. So while it is submitting, let me tell you what is the, so it's accepted. So what is the time and space complexity of this algorithm? The time and space complexity will be similar to the level order traversal of a tree. It would be order of 1, order of n, or rather linear time and linear space for both the cases, because we are just traversing through all the nodes in the tree. So that's why it's linear in time, and also we are using this queue, so that's why it's linear in space also. So that is pretty much it for this video. That is how you solve the right view, and also I have told you how to solve for left view also. So if you want, I will leave the link of the code for left view also in the description section. So thank you for watching.